Alex, make a start.
Okay. Okay, I'd like to introduce Pat Hale. Is that right?
Yep.
And he joined MIT in 2003. That was after a 22-year career in the U.S. Navy. He's currently the executive director of the System Design and Management program at MIT, and he's been leading the graduate certificate in Systems and Product Development, which is a one-year graduate certificate, pretty much the entire time he's been at MIT. His professional interests include the application of systems engineering in commercial product development, complex naval system design, and engineering process frameworks and materials. While he was in the Navy, he qualified in both surface warfare and submarine warfare communities, and he also managed the design and construction of submarines in Groton, Connecticut. He later held executive-level positions in a variety of organizations in both defense and commercial systems and product development, and that included the Director of Systems Engineering in two companies. One was Draper Laboratory, and the other was Otis Elevator. And at Otis, he blazed the trail for them in systems engineering. He basically spearheaded the organization and developed the systems engineering processes for Otis Elevator. And how many of you probably know, he was a past president of NCOSE. He's been in NCOSE since 1994. He's been 11 years on the board of directors. And he also has published papers in commercial systems engineering that have gone into the conference proceedings for both NCOSE and the American Society of Mechanical Engineers. So another mechanical engineer here. Somebody mentioned there were two, but there's at least three. He also holds a Bachelor's of Science degree in Geophysical Oceanography from the University of Washington. And he has an MBA from National University, and he also has a Master's of Science in the degree of Ocean Engineer and Naval Architecture and Marine Engineering from MIT. Welcome, Pat.
Thank you, Alice. That guy sounds boring. I hope we don't have to listen to him for long, but it's my pleasure to be here. I think I thoroughly enjoyed both the keynote and the first speaker, and hopefully I'll pull together something that's as organized. The main thing that I want to talk about is how you get into engineering and attempt to be truly multidisciplinary. All systems engineers are kind of automatically multidisciplinary, but there are a whole lot of engineers, including a bunch of them in my program at MIT, who have come through many years of electrical, mechanical, or one of the other traditional engineering disciplines. They all have a sense of systems, because you really can't be in industry for very long these days without getting that kind of a sense, but that's different than really being engineers who know what systems are about and have, as was mentioned by a couple of the previous speakers, if you ask 10 people, certainly 10 people outside of NCOSE, what systems engineering is, you'll get at least 11 different answers. This is kind of the context. I don't know of any component products anymore. There are some that become parts of larger system type products, but depending on your definition of systems, almost everything we see today is a system of some sort at a level of scale that can range from very small to huge. If you need more than one behavior from a product, you almost always end up having to put together several subsystems to do that. There are companies still around, unfortunately, that don't have any systems engineering organizations or don't use anything they would call systems engineering. As was mentioned before also, almost everybody does systems engineering. There are no successful companies I can think of that don't have something that approximates what we all call systems engineering. They usually don't call it that if they haven't had enough involvement with systems to know they need it in a formal sense. I think probably there are much fewer people who have degrees in systems engineering. I certainly don't. I mean, old guys like me didn't have systems engineering degrees they could take, but you kind of get it by having many, many years in different industries and different jobs, and that's probably just as good as any degree you can get. Again, for types of products that we all know, I think simple products are really not very prevalent today, and in most cases those that were have now been broadened to where they are much more of systems, small systems, medium-sized systems, because that's how you get enough of the value chain to make it profitable to be in business these days. You have to do interface management, and you really do need higher profit potential, which means you have to get more functionality into your product. That has been true, I think, for at least 10 or 15 years, and it's even more true today. I guess I was going to ask people, how many people know of a single discipline-based product? Unless you're in a pure science field, there's probably very few that fit that category. This is kind of one of my favorite illustrations of why we do systems engineering, and it's a fairly good question. We did rely, when I was first around in academia, it was not too surprising to find that there were very few systems engineering degrees. There were some, but there were a whole lot of people who were starting to do things that were spread across the engineering spectrum, and that's really how we, I think, grew up into the discipline we are today, is people who did many things in the engineering realm and then ran an organization and led people to go do the same, became people we now know as systems engineers. There is kind of one of the things I run into at MIT, I have a program that teaches people who have a lot of industry experience before they come into it, and one of the things that we run into is the taxonomy of systems engineering as we know it today, which is very broad. There are, although NCOSE has some pretty standard definitions, there are a lot of people who are in systems engineering who don't use NCOSE's definitions. And I think they have a lot more diversity in how they would illustrate what systems engineering is. This is kind of my personal view of many of the systems I've been around. There are lots of people who work on something together for 10 or 15 years in an industry, and then when you get together at the end of the program, you suddenly realize that nobody really knew what they were working on or why, and they can't define it in a way that everybody can identify with. That's probably still true today, unfortunately, and I think it's probably something we need to work on as an organization, is how do we get more people to think in a systems manner and understand that that's what they're doing. A lot of people do systems thinking now, but they have no idea that that's what it is. So it's kind of a little chaotic, as shown by the illustration here. And I think one of the things we all exist for is to help bring some order to that chaos and get people ready to think about both the discipline and a career in systems engineering. Why do we need it? This is a really trivial graph, but it's complexity and technical complexity and management complexity are going up in a, actually I should have probably put an exponential curve there, because it's accelerating every year. There are folks who do this in academia and spend lots of years doing research in this area, and they would all draw something of the same curve, although theirs probably would be exponential. So you get lots of things that you have prepared yourself for, and when you start working in this field, you find that there's a whole lot of things that you didn't know how to prepare yourself for. And if you take that in an open-minded and fun way, it becomes a pretty enjoyable way to make a living. If you are kind of uptight about wanting to know exactly what it is you're supposed to do, you're probably going to be really disappointed or bewildered, one of the two. This is kind of the way that most systems engineers who are somewhere near my age got there. You come from commercial domains with a lot of increasing product complexity. If you came from the aerospace world, you probably do know what systems engineering is, and there's fairly standard definitions that I think you'd find in literature for aerospace companies. But I think even if you have no background in it, you'll find that engineers are fairly methodical people. My wife would say boring, but I prefer methodical. And they really do recognize complexity, and being good engineers, they want to manage it. So it's a way of defining their career that I think helps both us and the discipline itself. And I think, frankly, what the best thing that I could say in terms of what we're supposed to be doing is hiding complexity. People who aren't experts in your field should be able to look at the documents and designs you create and not be bewildered. In fact, they really should not even know the technical details of what's there unless they're other engineers. If you can put a very complex product in the market and make it seem simple enough so that most people get it, I think you've been very successful as a systems engineer in doing that. One of the places that I grew up was Otis Elevator Company, and when I went there, I was coming from Draper Laboratory, which was still an aerospace-based organization. In fact, it's about 2 blocks from where my office at MIT is now. But Otis was a very interesting company, and this is kind of current statistics on it. They do $12.1 billion a year in sales. But the thing that I think impressed me the most is I was in their headquarters location in Farmington, Connecticut. There were 168 different countries that had probably 3 or 4 times that many Otis offices in it. And people from every culture you can think of were in the organization. We grew primarily by acquisition. So we would buy a company nobody ever heard of one day, and then the next day you'd see it listed under Otis's Holdings. And those of us who were in the management team would try and figure out, okay, who are they and who should be talking to them. So it was a fun place to be. It was a great job. There were probably, I mean, what I enjoy most about everything, including what I'm doing now at MIT and certainly while I was at Otis, is people. That's really what makes life worth doing, is you get to meet a lot of people, you get to lead them, you get to organize things for them. And I think if you are good at that, it doesn't really matter what your degree's in or what kind of preparation you've had. If you're good with people, you'll be pretty good at what you're doing. And that sounds simplistic, but I honestly believe it's true. It was true for me in industry, and it's true in academia. There are people at MIT who look at me with some odd expressions on their faces, but that's just me. So, here's kind of an illustration of complexity in a product everybody thinks is simple. And that included me when I went to Otis for my interviews. And I kind of knew what the company was, and I ride elevators, but I had no idea what was behind the elevators actually getting to where they were supposed to get to and doing it correctly every time. this is really a modern elevator. Even a fairly small elevator will have all of this as part of its makeup. And it's much more complex than most people think elevators are. So I think most people would not really understand why you need artificial intelligence and fuzzy logic and neural networks in an elevator, but you really do. We had banks of elevators that had 12 or so elevators in a bank, and when you're trying to coordinate those in a large building with all the dispatching and a bunch of people punching buttons throughout the building, it becomes pretty complicated. And Otis did a pretty good job of putting together some rules for dealing with all of that. This is the program that I run now, kind of my day job, and it's a great place to work. And I think when I went there, I was a consultant about 2002, 2003. And as I stayed there, the guy who I reported to as the director of the program decided to leave and go elsewhere. And I was one of the candidates for the job, and I think, frankly, the best decision I ever made was to apply for that and take the job. I suspect that will be the last thing I do professionally for the rest of the time I'm around. And about that same time, actually a little before that, I got involved with NCOSE. And I'd have to say that's also been one of the most interesting and rewarding organizations I've been a part of. And I have some friends in the room. There are current officers of NCOSE in the room, and there are Donna Rhodes, who I know I'm not supposed to sing you out, but she's another former president of NCOSE. And I love the people that I meet in NCOSE, and I like building a network of people who don't necessarily think like me. It'd be really boring if they all did. But they are all interesting professionals with a very complex and rich background, and they're great people to interact with as you are moving through the rest of your life. And that's really all the slides I have. I was trying to keep this short and simple, but hopefully it gets across some of the central thoughts that I have on this, which is it's really the people. It still boils down to understanding not only the corporate motivation for the companies you're dealing with, but even more importantly, the personality and motivation for all the people that you're dealing with. And that every day is the reason I'm able to survive, I think, because I typically have about 200 students that are in one phase of the program or another. And I have trouble remembering my name from day to day, let alone trying to remember 200 of them, but they are all great people. It makes it fun to come to work, and I think it's probably one of the things that I count as the best part of that job is staying interested in what you're doing and staying close to the people who are going to be the next leaders in the profession we're in. With that, I'm happy to take any questions you may have. Yes?
B.J. Canabar from Boston University. I direct the project management program. In 10 years, we have moved from 0 students doing masters in project management to 400.
Yep.
Some of my students are systems engineers and working in various sectors, aerospace, the elevator, Otis, you name it. A question that comes up is, what's the difference between the role of a project manager and the role of a systems engineer in the classroom discussion? So I'll take your thoughts and let's see what you have to say.
If you look at what we do in general as kind of a broad set of disciplines, I think they're both in the same spectrum. The project manager tends to have an overall responsibility for budget, organization, time. The systems engineers tend to be the more technical side of that spectrum, and most of them that I know have traditionally had a foundation in some individual engineering disciplines. They usually know that quite well. It kind of changes the way they think. about how they do their jobs. Program managers may have the same kind of background, but by the time they get to that, they're spending a lot more time, and rightfully so, thinking about scheduling and the interrelationship of various tasks that they're trying to manage, and how do you lead a program rather than leading individuals. So that's a very common thread that ties it all together. Does that answer the question?
Yeah,
Okay.
very good.
Yes.
Hi, I sit on a international project management committee of the International Astronautical Federation, and it's a collection of various space agencies in the world. And one of the programs that we run is for what they call young professionals. So a lot of them engineers coming out of school, working for NASA, the space agencies, and so forth. And in talking to some of these, people, the young men, both coming out of business programs and engineering programs at the undergraduate level who are now working together, they say that one of their major problems is being thrust onto a project together as they graduate and come into a real-world experience without understanding the mindset of the other. And I'm looking at your program, looking at the certificate of master's, and saying, when I talk to people at NASA, they say, well, we hire a lot of people with undergraduate degrees that have not advanced yet educationally, and they're in those kinds of situations. So I'm wondering, and you spoke earlier, focused on the undergraduate, and it looks like you're focusing on the masters. I'm wondering if there's a way to in the school setting around internships, research, class projects, to bring those two groups together in some kind of a co-op situation, or where they could really learn the mindset, because the mindset for business is so different from the mindset from engineering, and that's what they said over and over again to young people. Just wanted you to talk.
I think that it's not only a good question, but it's kind of what makes up a lot of our day-to-day management of this program. That we have, at any given time, we typically will have each fall about 60 students coming in, and then we have a certificate program that runs 40 to 50, and we'll have 2-year groups there most of the time. So our core course, which we re-architected this year and taught for the first time, is a combination of what used to be 3 separate courses, and it had 140 students in it. So we were all relatively busy teaching it. There were 6 full-time instructors in it. So, but I think that's really what we ended up doing, was thinking about, if I'm going to do this and take people that literally run from single discipline background at the bachelor's level to about 60% of our folks have a graduate degree already, usually in the same field that they got their bachelor's from. So what we do really is we put together something that has enough hands-on project experiences to let them demonstrate both what they're good at and let them learn how to do other roles in a product development team. And our students continually surprise us with how good they are at adapting to that. They shouldn't, because we've been around them for a long time, but it's a rich environment to do that kind of work in, and frankly, it's why I keep getting up in the morning and going to work there. And if you asked me when I was going to retire, I'd say, I don't know. I may not. Yes?
How do you teach using system thinking to solve large-scale, complex problems in product design, development, and innovation?
We tend to there are a lot of things, there's no single answer to that, but I think what we do pretty much universally is the kinds of issues and problems that we have them do in class are things that can't be solved with, even if you're an expert, with any single engineering discipline. Our average student has about 10 years experience before they start the program, so they are actually very bright people who have demonstrated they know how to do a job and do it well. And I think they bring more into answering that question than any of us on the faculty does. So They tend to be very broad in their thinking, and when we toss out a problem or a question, you get an extremely rich set of answers from people who have very strong academic backgrounds and very strong practical backgrounds from industry. That's frankly what the students in my program actually do a lot more of the teaching, and we kind of design it that way. They don't think they're signing up to do that, but they do. But they teach each other at least as much as anybody on the faculty does. And it's very, I think it's interesting because as the program has grown, the variety of professions that have become involved in it has been increasing too. We have doctors, we have obviously engineers, people from pure science backgrounds. It's a really broad set of folks that tend to teach us at least as much as we teach them. And that's what makes it fun to do. Yes?
So, one thing I know you and I share on other things is that we both worked in defense and I did our stint in commercial, and value what we learned there. And part of the STM program that I enjoy being involved with is working with so many people from different domains. So maybe, I think you probably have some good perspective on this from personal and professional aspects. You talked about multidisciplinary, but
Yep.
how important is multi-domain knowledge for engineers, and how do we go about creating that?
Yeah, I may not give an answer that is strictly confined to basically, I think for a program such as ours and for a career such as I've had, I think it's crucial to have that breadth of experience, and I think it's also what helps you stay fresh and learning things. It's very difficult if you've been in one job for 20 or 30 years, which I sometimes thought, gee, I wish I had one of those careers where I'd be looking for my gold watch and getting out of here. But it's not that simple in the real world for most people, and I think that's actually what makes it fun. In having all those different disciplines that you're working in and domains that they're applied, you learn a lot just from preparing for a class or meeting. I always interview all of our students individually when they come in, and I interview them all when they leave. And those are very interesting conversations. And they often bring up things that we didn't really know we were teaching them. They're not in the syllabus anywhere, but they seem to have learned them quite well. And that's...
What do you estimate the percentage of STM students that go to a different domain after they graduate?
Probably, if they are coming in without having a company sponsoring them,
Yeah.
I'd say about half to two-thirds. They often look at this program as a way to do a shift in their career focus. And they all seem to do pretty well. So, yes, sir.
Is your program like case-based or project-based? And if so, how do you get those things?
Yes. It's,
Where do you get those things from?
we get projects. I mean, the great thing about having a program that's set up for mid-career professionals is you get an awful lot of the examples from your own students. And we'll often structure sessions so that we cover a topic in kind of a generalized sense, and then the students will often do a report on something that is their own experience, but broadened to encompass all the things that we have talked about in the last 2 weeks to a month. And they actually bring some, we've had with the MDs now, we've had people bring in medical examples. One of my associate directors is a woman from the medical space who's been 25 or 30 years doing the practice of products for product development for medical community. So we have physicians in the program, we have astronauts. I mean, it's a very diverse student body that I think is what gives the program its flavor. The faculty doesn't do anything in particular to make it a different program like that, but we do heavily use the students themselves to bring that variety and thinking into the classroom, and they do very well at it. Yes?
So very interesting. I don't know how to phrase this and retain the flavor that you're putting on it. That the human side, the human activity side, it's not in the CBOC. It's hard to put in the CBOC. It's hard to say that systems engineering requires being able to empathize with multiple perspectives and appreciate their values and their concerns and integrate all of this and lead and enjoy yourself while you're doing it. And maybe the only thing that one can say is, well, if you've been through engineering education yourself or engineering practice, then you'll appreciate better, maybe more than a project manager would. You'll know where the engineers are coming from. But I don't know. I really like what you're saying. I don't know how to encapsulate it so we can get it into the CBOC.
Yeah, I'm not sure. Obviously, I'm very familiar with the CBOC and with the NCOSE products that are around that space, and I think it flows into there mostly from individual members who have had a very broad set of backgrounds. I don't know that anybody could write down in the handbook or any other place everything that we all think of in doing a systems engineering job, but it's to me, that's the richness of systems engineering. When I first started in this field, I didn't know what I was, so I just kind of kept doing whatever I was asked to, and slowly but surely it picked up a lot of responsibilities that forced me to learn some new areas. And frankly, although a lot of people tend to think of the military as a fairly rigid and stodgy organization, I probably learned at least as much from the 22 years in the military as I have from jobs since that time. You learn a lot about leading people, and that's really what's helped a lot. Yes, Fred.
That's actually something John and I were talking about just before the break. Maybe the only answer is that there are people in NCOSE. I was going to say people like Pat, but I'm not sure there's anybody else like that. But there are people in NCOSE and in the other communities with this sort of understanding who maybe we could encourage to go and talk to engineering masters students to give this perspective. Maybe that is the only way. That this end of I think we've had a quite interesting spectrum here. We've had what are the most important things to tell undergraduates to get them thinking about this stuff, and we've now got mid-career professionals who sort of are ready for this and know it and just need to be put in a room together to figure it out. And somewhere in the middle is more traditional master's education. But I think maybe just getting people to go to those programs and give them this message is probably the kind of thing maybe we should be thinking about alongside written and more formal products to pass on that. Certainly I did a master's mid-career, and I remember someone coming along and giving a similar kind of talk that resonated very much with me, that these things are possible and there are all these perspectives and you can move in that direction. Maybe that's one of the things we could think about in terms of delivering that. Not really a question, but...
Oh, that's okay. I've known Rick for quite a while, and I know sometimes his questions aren't questions, but that's great. That's the great thing about Rick.
All right, great. Thank you. Is that it from everybody? Thank you very much, Hal.
Thank you.
And I don't know who asked about the cases, but in case you're not familiar, we have check part 7 of the cbocwiki.org.
Yeah, there are some case studies in there, and maybe again case studies is part of the answer, but
Well, it'll lead you to other case studies. It has references. Oops, sorry.
Thank you.